The graph of a quadratic function has an x-intercept at 6 and a maximum at 4, 12. Write the equation of the function. So we have to figure out how the function looks like with these specifications. And the best form of a function in this case is the vertex form of a quadratic function. And we all know what is the vertex form of a quadratic function. The vertex form of a quadratic function is f of x is equal to a times x minus h whole square plus k. And this a is the leading coefficient. A is the value that is at the beginning, ax square bx plus c form. The same a is here that tells you about the stretch, shrink, and opened upwards, downwards, and all that. And this h comma k, these two will give you the vertex. The vertex is h comma k. Now already you know the vertex. They gave us the vertex is at 4, 12. Okay. So what you can do is you can just substitute the value of h and k in this function and start moving from there. And I want to show you here how the graph will look like, because the x-intercept is at 6. So that is, the graph of the function should intersect the x-axis at around this point at 6, 0 precisely, and the maximum is somewhere here. And as you know that it is a maximum value, the graph is going to look like this. It is opened downwards. Okay, so I'll have it like this. I change. Okay, right. Approximately your graph should appear like this. All right. So once again I'll go here. Now this f of x is equal to this a. I don't know what is the value of a. I'll hold on to that. X, then minus this h is how much? H is equal to 4, and that is your axis of symmetry also. The x coordinate of the vertex is the axis of symmetry, right? Plus k, and the value of k is corresponding to this second coordinate, the y value, that is 12. This 4, 12 you copy it here. Okay, so a part of our problem is solved. We made use of this vertex form and substituted the values of those vertex. Now you have one more information. What is that? They're telling us that the x-intercept is 6, 0. So this tells me that if x is equal to 6, the value of y is equal to 0. That's what you have here. Okay, so the value of this function, y value is nothing but the value of the function. This f of x becomes a 0. So let me do that. Now f of 6, that is, I'm substituting 6 for x is equal to a times this x again, 6 minus 4 whole square plus 12. And what is the answer to that? What is the value of this function? That f of 6 must be equal to this is 0. That is what it is, 6, 0. So I'll write a 0 here. Okay, so next thing, I'll simplify this. Okay, this f of 6 equals 0 you already have here. So I'll just take off this part and start from a times 6 minus 4 is a 2 and a square, 2 square plus 12 is equal to 0. So in the next step, I'm going to, I have to find the value of a. So let me write both the steps without skipping anything. Okay, 2 square is 4. 4 times a is 4a plus 12 is equal to 0. Now, as you are trying to find the value of a here, this is the only thing missing now. So we need to find the value of a. So let us do that. First step towards getting that value of a is subtract by 12 on both sides, leaving behind 4a is equal to this 12 cancelled, negative 12. 0 minus 12 is that same negative 12. Then divide by what? This 4, because I want to make that a by itself. So you are left with now 4 and 4 cancelled. Your answer is a is equal to negative 12 over 4. 4 divides 12 3 times with a negative sign. And you ended up getting the value of a. So a is equal to negative 3. And I'll go ahead and substitute in this function. Okay, so what is it? Now f of x is equal to, my final answer, f of x is equal to a is how much? Negative 3 times x minus, let me go back there, see, x minus 4 whole square plus 12. So x minus 4 whole square plus 12. This is the function which is satisfying the conditions. The given condition was what? The vertex was at 4, 12. See, that vertex is 4, 12. And the x-intercept 6, 0. So that I can verify using Desmos. So I have Desmos here. And what is the function that we have? F of x is equal to negative 3 times x minus 4 whole square plus 12. So f of x is equal to negative 3 parenthesis x minus 4, close the parenthesis, and the square x minus whole square plus 12, right? So this is what you have. This is the function. Let me just reduce it. Now f of x is equal to negative 3 times x minus 4 whole square plus 12. Let us see, look at the x-intercept. See, that is 6, 0. And the vertex is at 4, 12. So the conditions are satisfied, and we can make this graph look better by fixing the settings. But we are not worried about that now. So just I need to verify and make sure that this function is according to the given problem, where it stated that the x-intercept is 6, 0 and the vertex is 4, 12. Then this is your final answer. Okay, and the process is simple. Just use this form. Make use of the vertex form of a quadratic function, and using that vertex form of a quadratic function, I substituted my first, what did I do? This vertex 4, 12. I substituted for x and h and k, then simplified by going back and again using this x-intercept. So two things you have to do. Those are the two informations they gave. But first use the vertex and then use this x-intercept. That simplifies. Okay, and rest of it is very easy. Find the value of a through this regular simplification, and then go back and substitute the value of a in that function on the top. Okay, thank you.